Hello friends, in this particular video we are going to learn about types of evaporator. As we know that batch process cannot handle temperature sensitive and also needs a very long residence time. So it's very important to learn different types of evaporator. Evaporators can be classified as natural circulation, forced circulation, others based on the flow of the liquid. Natural circulation can be further classified as short tube and long tube vertical, whereas others can be classified as rising film and falling film. So, clean fluids generally are being preferred for natural circulation. When you have highly viscous, suspended, or the one that scales, we can go for forced circulation. Now we are going to learn about horizontal tube evaporators. These are one of the oldest type. Over here it is called as horizontal tube as the steam flows in the horizontal tube. The major advantages it has got a small headroom, it requires a lesser space, and the disadvantage here that it cannot be used for the fluids that form scale or deposit salt. Talking about short tube vertical evaporator. These are called as short tube because the length of the tube is about 1 to 2 meters in length and the diameter is 2 to 3 inch. Now what happens over here is the feed is flow into the particular evaporator. It goes down and it is being heated by the steam which flows in the cell side and the liquid flows in the tube side. Now, the advantages of this particular evaporator is that it has got low head space. It is used for easy cleaning. It has fairly high heat transfer coefficient, and it is relatively inexpensive. So this is like kind of one of the cheapest solution. Now, when we talk about disadvantages, it cannot be used for viscous substance because it flows in the tube. It has got low heat transfer area, and it requires more flow space. Now flow space is this particular area. Now talking about the applications, this can be used for clear fluids or crystalline products if the propeller is being used or for a non-corrosive liquid and mild scaling solution. Since tubes are being involved, we cannot use a very high scaling solution. Now, talking about propeller calandria. Now, for example, if we told about my scaling, so we need to provide propeller. Now, why propeller? Because it increases the heat transfer coefficient. Now, this is used to avoid suspension. So, whenever you have a suspended solids, you can use this. It increases the heat transfer rate and it also doubles the capacity of the same short tube vertical evaporator. But it also imparts a mechanical energy. Now, talking about long tube vertical evaporators. These are called as long tube because the tube length is about 3 to 10 meters in length. So these are, as you see in the diagram, these are usually very long. Here the steam flows into the shell side and the particular feed flows into the tube side. The major advantage it holds is its low cost. It has got a large heating surface area because of the tube length, low holder, small floor space because we increase the length, and a very good heat transfer coefficient. Now the major disadvantage it has got high headroom because of the particular length, and it is not suitable for salting and severely scaling liquids, and foaming cannot be allowed in long tube vertical evaporators. So it is generally being used for clear liquids and one which has got a large evaporation loads. Some of the common uses of this particular evaporator is in cane sugar syrups, black liquor, nitrates, and electron tiny liquors. Now talking about another type of evaporator that is called as forced circulation evaporator. The forced circulation evaporator, as we know, involves the use of pump. As we have low heat transfer, we increases the fluid velocity, and this particular fluid velocity increases the heat transfer. So basically, the advantage over here is that you get high heat transfer coefficient by providing an external pump. It goes for a positive circulation and it has got relatively freedom from sorting, scaling, and fouling. But the disadvantage is it is high cost. We require power for circulation, and it has got a relatively high holdup and residence time. So the best application of the next is falling film evaporators. The basic idea in this particular reactor is that the liquid is passed as the falling film in the evaporator. It goes down by the force of gravity, and evaporation takes place within the tube, and the vapor forms above the tube, whereas the concentrated liquid flows below. Now, the relative advantage, it is has low cost. Because of this film thing, the heat transfer rates are generally very high. It has got a large heating surface area, low product holdup, and small floor space requirements. So these are the advantages of falling film evaporator. Now, talking about disadvantage, yes, it requires a high headroom and is generally not suitable for salting or scaling materials. And sometimes recirculation is also necessary. Now, when we are talking about heat sensitive thing, it is used for concentration of dairy products, like you have milk protein, cream, and hydrolyzed milk. So, falling film evaporator can be used for that. It is also used for sugar solution, urea, phosphoric acid, and black liquor. Now, next talking about climbing film evaporator. So this generally comes in the combination with the rising film. Now, let's learn the major difference in climbing film is that the liquid has the flow like those of the in boiling. So it has first liquid, then small bubbles are being formed, and then the large bubbles are being formed. So this is how the liquid flows above and the evaporation takes place. So generally this has got low residence time because going down takes time, but this has got low residence time. It has got high height transfer rate, low cost, large units can be manufactured, low holdup, and small space requirement. So disadvantages, it still requires a very high headroom, recirculation can be used, and even this climbing film is not being suitable for salting and fouling industries. So this can be used for handling clear or foamy liquids, and whenever there are large evaporation loads, we can use climbing film evaporators. Now talking about agitated thin film evaporator. Now what happens over here is that you can see that feed flows inside it, and there is the propeller here. So we have the as we can see in the diagram, the liquid flows in this particular manner, forming a very thin film, and at the same point of time we have even provided mechanical agitation. So this the major advantage over here is it has got a very short residence time. It could be only seconds or minutes. It has got a high heat transfer coefficient because not only thickening the film, but at the same point of time you are imparting turbulence. It has got plug flow, ability to handle a high solid concentration, less product decomposition, and high recovery because of squeezing. Now the major cost, this particular equipment is so sophisticated and it requires a high cost. So where do we generally use? It is used for purification of very sensitive organic chemicals. This includes your natural oils or fatty acids or isocyanates, and it is used in concentration of food and pharmaceuticals. So in pharmaceuticals also, because they are very temperature sensitive and requires a very small residence time, this can be used. And it is also recovery of valuable resources from waste streams, it purification of paints. So it has been used in this type of product applications. So it is used in pharmaceuticals for temperature sensitive materials. Now talking about gasketed plate evaporators. Now gasketed plate evaporator works similarly like plate heat exchanger. Now in plate heat exchanger you have different corrugated plates placed with each other. So in this particular compartment you will have your feed being flown here, and in this steam. So consecutively you will have feed and steam, and there would be a various plates being placed here. So the major advantage is it is used for evaporating heat sensitive liquids. It has compact with low headroom, so headroom is being less, and it is easy to clean and modify. You can disintegrate the plates, but the major disadvantage is it requires a very large gasketed area. So this is about gasketed plate evaporators. When to use which type of evaporator. So basically for clean fluid you can either use batch horizontal tube or vertical short tube evaporator. For a higher capacity you can include vertical long tube and rising falling film evaporators. Now only falling film can be used for all type of liquid except the one that fouls and for viscous liquid. Now force circulation, as we know, cannot be used for temperature sensitive and viscous, because viscous will need higher pumping, and temperature sensitive because of the pump's flow, temperature sensitive material can get degraded. And plate and agitated can be used for all type of fluid which is clean, having high capacity, solid crystals, fouling, foaming, temperature sensitive, and viscous material. But the only problem with this is they have a very high cost. So based on your application, which type of fluid you are using, you can design that type of evaporator. So hope in this particular section you are able to learn about different type of evaporators and when to use what. Thank you.